Hello, hello. Oh, I just lost my board. Oh, yeah, yeah. Hello. Say hello more properly in a minute. I just lost my board. Sorry, my board always cuts class. It's so irresponsible, and I do take it personally. Hold on. And someone had just anyway. All right, hold on. The board's coming back. Okay. Um. Okay. Hello, hello. Okay. So first of all, oh, there's more people in the waiting room. Okay, so first of all, hello, Ashton. Hello, Giselle. Hello, Eugene. Oh, she even wait. That totally counts as class participation. You totally submit that in the portal. That's totally. Hello, Catherine. Oh, and you're showing video. This is so exciting. I said hello, Ashton, and Ashton even sent me a question. My hello, hello. That counted as part. Also, yeah, if you sent me questions, whatever that you guys were already participating, like up the was. Hello, hello, and remember for those of you who even just saying hello at the beginning with your voice or in chat, whatever, totally counts. So I encourage hello, Sylvie, good to see you. Hi, see, that counts. Like Ariana, hi, how are you? Totally counts. She should submit that. Hello, Giselle. See, that totally counts. It's points. You just like, we're just on the road to an A here. Hello, Fatima. Hello, Abigail. Oh, look at that. See, this one of, if only life were like this, right? I mean, what a community. I feel like we've already learned physics. We're done. Excuse me. Oh my God, and you guys are behaving better than my board. I'm about to lose the technology again. Sorry, but yes. Hello, Ari. I mean, hi, Ariana. Thank you so much. Hello, Giselle. Hello, Jonathan. I didn't even see. Wait. Yeah. Hello, Jonathan. Thank you so much for saying hello. Hello, Fatima. I mean, Fatima. I think Fatima. Sorry. Hello, Abigail. I mean, Abigail. No, I'm just kidding. Okay. Good afternoon, Sylvie. Hello, Ashley. Hello, Dewin. I think it's Dewin. You should tell me in the chat if I'm doing the accent wrong. Good afternoon, Jake Moses. Hi. Oh, so lady, see, it's interesting. See, she thought of everybody. See, what a community minded. I mean, right? Like I was just thinking of myself and you, but she was like the whole group. Anyway, hello, Sulady. That's awesome. Not oh, and Eugene is now taking it. See, we're escalating. If we keep this up, we'll never have to do physics for 2.5 hours. This is awesome. No, yeah, thank you. So Eugene escalated tonight. She's actually like being friendly, cool. Okay, hello, Isabella. Hello, Kayla. That's awesome. And I hope you all understand that all my silliness is just silliness. Actually, it's not, but you know, it's all in affection. Okay, so wait, we said hello, Ashton. Oh, and she's even smiling. That makes me so happy too. Hello, Giselle. I'm just going back through the video again. Hello, Eugene. Hello, Catherine. Hello, Sylvie. Hello, Kayla. Hello, Sulady. Hello, Ariana. Hello, Marina. We won't do this all.
Hello.
Oh, whoa, she went voice. She went voice. 1,000,000 points. I can't even count high enough for how many participation points she just got.
Yay.
She see,
Hopefully
yay.
I get an A.
So I think you will. Just keep it up and you will. And it won't come from me. It'll come from the justice of the universe. It's awesome. And honestly, have you guys noticed in COVID that honestly, you might think physics is a little hard. I don't know. Or you might have thought it was in 101.
Extremely.
Oh, extremely. Oh, we should talk about that too. Okay, we're hopefully going to learn harder physics this semester, but somehow make it easier. That's the goal. The goal is not to be a joke. The goal is to learn actual hard physics, but to somehow make it easy. Honestly, that's always my goal. But so good. So we'll bear this in mind. You'll tell me how we're doing as we're going. But I gotta tell you, in this world of COVID and whatnot, like as hard as physics might be, actually being like happy and serene and calm and unstressed and confident and hopeful in life is even harder, ain't it? So all your energy, all of you who are saying yay and hi and all this, I think it helps us all. Oh, and then 1,000,000 points. Oh, and then someone oh, well, thank you for thank you, Ariana. And flattery will get you everywhere for sure. No, but thank you. And thank you, and 1,000,000 points. Yes, okay. No, and look, we'll do whatever we can to keep the energy going here. I mean, Zoom sucks, right? I mean, so let's make it as unsucky as possible. That's the goal. I mean, Zoom and physics, that's like the worst combination ever. I mean, obviously, I don't really believe that, but I believe that if I weren't me, I would believe that. Okay. So cool. So hello, everybody. We do have a lot to do. This is great. Let's keep it up. We'll keep up the energy. We have stuff to do. And I won't just be talking the whole time. We will have time and break. We'll always be, oh, and there goes my board again. Oh my God. And even in the last class that I just had 1 minute before this, someone even went online to research like why my board keeps disappearing like this, and they actually tried to help me out and gave me a good piece of advice that I thought was right, but apparently I'm not following it. Hold on, I'm putting the board back. I mean, I think we do need the board today. Okay, the board is coming back. We hopefully I won't like lecture for 2.5 hours. So we will have time in breakout rooms to try to do work and stuff like that. We have a lot to talk about and a lot to do. Like my main, all right, let me back up for a second. The main goal, sorry. All right. Back to earth. Okay. Sorry. Oh, someone's here. Someone's in the waiting room. Oh, someone who lost their device. Okay. Let me say a couple of things. Number one, if we get to what I want to get to today, if we get to the material that I want to get to today, then one good news of that is there won't be a new homework sheet assigned for next week. Like we're going to stay on this, the homework that I think was called homework 1B, the thing on the spring. We're going to be dealing with that sheet for a little while. Like there's a lot going on in that sheet. There is. It gets hard by the end. So the good news is if we can get to what I want to get to today, we're still just going to have that sheet in the docket due for next week. Like I'll change the deadline in Google Classroom. And by the end of this period too, those of you who have already made some attempt on it, like I asked, and in fact, there goes my board again. Oh my God. See, the reward for the worst energy in this class definitely goes to my board. I mean, I guess because my board has to sit and listen to me all day. So my board gets bored, I guess. So it keeps like checking out and going to get its own cup of coffee every 5 minutes. It's driving me crazy. Yeah, drive me crazy like I wasn't already. Okay, all right. I'll put the board back in a second. What I'm trying to say right now, actually, let me say this right now. Hold on, bear with me for a second. What I want to say right now. Okay, I'm going to do something a little slightly risky here. Talk about energy and humanity and all that. Slightly risky. Bear with me for 1 second. Right. Okay. Well, homework 1B, many of you have already made a very valiant attempt on it. You've already started it. You already got very far on it. You did exactly what I asked, which is you made a really good start on it for today. I'm going to acknowledge those people in one moment. By the end of today, too, just for the fact that you've already made this really good start and the fact that you're going to help each other with it at some point, by the end of today, you're going to get a lot of the points on it. I'm not sure how much direct feedback just yet you're going to get on it. And if you already turned in a homework 1B, you have not gotten it back yet, and I'm aware of that. I'll acknowledge that in a second. By the end of today, even if you don't get direct feedback on it, you're going to get a lot of points for it. Okay, but all of us are still going to need more time to fully finish it. And some of you who have not started it yet, you still absolutely can, and you will still get points. And all of you, whatever tracks we make and me starting to help you with it, can use that to either correct or improve your homework or start it. And it's not cheating. And to that end, let me just say for a minute, some of you have not started yet. I'm not looking at who you are. I'm not mentioning who you are. There's no shame, like no problem. But I do want to say, like, it is just so that you know that I know, like, I'm totally aware and thanking and acknowledging you, Isabella, Sylvie, Abigail, Ashton, Kayla, Eugene, Jake, Moses, Marina. Wait, is Moses your last? Wait, yeah.
Moses is my last name.
Oh. And by the way, thank you for using voice. That's points. That's totally, you should totally submit that for points. Oh, I'm sorry, because there was no space in the thing on your thing. I totally thought that was your full okay. Well, okay, my bad. That's a great last name too, I might add, but okay, I'm sorry. I was reading that all as your name. Yeah, you know that I know. Okay, got you. Thank you. Much clearer now to me. Okay. Right. And thank you for using your voice. Okay. And right now I'm not even looking at the screen, guys, by the way. Like I can't see what anybody's faces are doing because I'm looking at the Google Classroom right now, but all right. So I'm acknowledging, I'm just saying to Isabella, to Sylvie, to Abigail, to Ashton, to Kayla, to Eugen, to Jake, to Marina, to Jonathan, to Ashley, to Giselle, to Devin, to Catherine, and to Remy. Yes, all of you. Oh, and there's more people in the waiting room. Sorry. All of you, if I mentioned your name just now, that means you have made some attempt. That means you have turned something in and tried. You might have already I know some of you got stuck very early. Some of you got stuck. Some of you were frustrated, but you have made an attempt, and I'm totally acknowledging that. And you haven't gotten points for that yet, but just know that I know, and you'll get the points by the end of this period. And also, again, because you're getting to know me and I'm getting to know you, this is how I roll. Like, I'm not saying anything about anybody who didn't do it. It's not a criticism. It's not a shame. You still totally can. I don't even know who you are if you haven't done it yet, like, honestly. But if you have, I want you to know that I know. It's like that. And you will get points by the end of this period in acknowledgement of that. But then still, and so I don't want you to think your efforts were wasted, is really what I'm trying to say. But everybody's eventually going to get there, and everybody's eventually going to get all these points if they want them. And everybody's going to get this right with or without help from me. That's how it goes. Okay, but those of you whose name I just called, like, thank you. I get it. You get that. I get that. You get that. I get it. I think, I hope. And that's number one. Then number two is if you get to where I want to get to by the end of today, and there's more people in the waiting room, that will mean that I will have helped you make more of a start with that, or I'll show you more what I'm looking for with that homework. And you won't have any new homework sheet due next week. It's just more opportunity to either complete that, move farther with it, or correct it and re-upload it and improve it if you think that what you're doing so far was like not what I'm looking for. Okay, so there won't be new homework next week. That's the good news. But I keep saying, but that's assuming I get to where I want to get to by the end. I keep saying that. So where is it that I want to get to by the end? Well, my primary goal of today is I want to set you up for the next lab, just like I hope to have tried to have done with you last week. Like, so even before we deal with this homework stuff, and even before we go into breakout rooms or anything like that, like, I want to make sure we're set up for the lab for next Monday the way I want to do. So maybe I really don't need my board for, well, I will need my board again in a minute, but so in order to do that, in order to set you up for the, because it is a lab, you know, it's science. I mean, hopefully what we're talking about in theory is like all related to or being fleshed out by what's going on with your data collection and so forth. So in order for me to set you up for the next lab, you might see where this is going. In order for me to set you up for the next lab, I want to talk in a human, informal way, in an honest, open, but considerate, sensitive way about whatever might or might not have happened in the lab last time. I have questions for you. This is a discussion. We will take some time with this, especially because you're new to that lab and your lab instructor is new to you. So let's make sure this is all like working okay. I have, and of course I have spoken to your lab. Like I've gotten her read on what happened. So I'm like not, you know, totally in the dark, but that's her perspective, right? And by the way, from her perspective, you guys did great. Just let me start with that. Like she certainly didn't, I mean, she certainly thinks you guys did fine and she feels good about what you did. So that's good. And you should know that. So thank you and yay. But now having said that, let's be like more concrete. First of all, do you guys, oh, and let me look in the chat. Wait, someone's in the chat. Oh, yeah. Wait. So someone's asking me, maybe I don't know if this might be a stream cross. This might be a stream cross, but let me be totally, because someone in the direct chat has asked, they said that they struggled on the homework assignment. Is it okay to submit it later on? Yes, is the answer to all of you. Like I'm yelling because I want to make, there's nothing about, I totally understand why that person put in the direct chat, but there's no shame or embarrassment here. Let me say to all of you, you all still have full opportunity to get all the points on that homework. Like, and I will be saying more to help you with it. And you can use what I say to do it, all of you. It is not at all too late. And I'm going to repost it for next week. I mean, I'm going to change the assignment date for next week, but so yes, there's still plenty of time to do that homework. And if we get to it today and I start saying things that show some of you that what you were doing was like totally off base, you also can change what you're doing and get all the points. Wait, let me stop right now before I go any further. Is that clear to everybody? Okay, all right, cool. And look, and also because you've already gotten this far in science, you're already in physics 102, like you already took 101. Let me also say, the reason that I do this cheesy thing at the beginning of acknowledging who's already made an attempt or who's already turned it in, because I also want you to know, if I keep saying, oh, it's not too late, you can still get all the points, oh, don't worry about it, it's due next week, which I do mean, but I know there are some of you who are like you work very hard and you've been doing this for a while, and you care about your achievements and you take deadlines seriously and you take instruction seriously. So I know from experience that if I keep saying, oh, don't worry about it, you can re-upload next week, or don't worry about the, I know some of you have every right to think, but wait, I killed myself to get this crap in on time. Like I totally killed myself to give him something for today. So now he's telling the other people who didn't do it or whatever, like, it's okay, they can do it next week. So why did I kill myself? Or what is this all about? Like what, like maybe I'll just like kick back. So I'm saying, no, it's, if you did kill yourself to already hand it in, that's one of the reasons I'm like publicly acknowledging you right now, or whatever, acknowledging you, and also saying you're going to get, and that's why I haven't changed the date on it yet, because I will first give a bunch of points to the people that already made a big attempt when it was due, then before I change the deadline. Then I'm going to change the deadline, and then everybody's going to get a chance. So again, and this is a fine line that I walk, but I want to make it clear to all of you, especially in these crazy COVID times. Like, this is a fine line I want to walk, but what I'm saying is it's kind of like capitalism with a safety net, if that meaning what I firmly believe is that all of you should constantly have a chance to be okay in this class. All of you who fall and dip or have struggles or have other things going on in life should always have a safety net where if you want to try again and improve and do better and do okay, there should always be a chance for all of you to do okay. But those of you who can do it without that chance, and those of you who are superlative, should also be therefore acknowledged as superlative. In other words, everybody, I hope you get my point. It's all about good and great, not bad and worse, if that makes sense. Anyway, okay, I think you get it. So that, I hope you get it. And if you have if you ever have any issue with any of this, tell me in the chat or text me. Like, and again, everything I'm saying would really be bothering me. If I were one of you, I would think this was all a big mixed message, except for the fact that the main message I'm saying is you're not in competition with one another in my class. All of what I'm saying would not make sense and be very confusing, but for the fact that I'm saying that if you all end up earning an A by one method or another in this class, then Quark bless America. Like, it's okay as far as I'm concerned. It's good, right? So as long as you remember that your A is not threatened by somebody else's A, then hopefully all of what I'm saying actually makes sense. Anyway, okay. Oh, thank you. Oh, I saw that face. Thank you. Okay, or I think I did. Okay. Oh, I saw two faces. Wow. Okay. Wait, that means we're two-faced. No, it doesn't. Okay, so back to the lab. Here's my first question. Do you feel, and I really want to open this for conversation, like use your voice, whatever's comfortable. Like, do you feel that you got to a conclusion in the lab? So, okay, I'm seeing like thoughtful faces. There's like, well, there's, okay, well, but yeah, all right.
Can I say something? Do you
please,
mind?
Please, yeah,
okay.
Please, yeah.
So it was a lot of like discussion, and we were kind of all stuck until we figured out that we could like derive K, and then like you know, like, you know what I'm talking about with the K that we had to do. But like, once we figured that out, it like kind of fell into place, and everybody, it was like, it was a big discussion. It was kind of like we all kind of discussed it in our groups. And then she kind of brought us back and was like, oh, you do this. And we were like, oh, cool. And we like, she kind of led us to that. She didn't give it to us, obviously, but she led us to that, and it went pretty well, I think, in my opinion.
Wait, wow, that's a lot. Wait, that's actually kind of amazing. No, that's great. And I understand if you're, wait, okay. Well, first of all, no, that's great. I mean, if there was like, if you're telling me that there was like stuckness for a while that then turned into like discussion, but then turned into clarity and then resolution, like, first of all, that sounds like a lab to me. That's kind of amazing. That's cool. Wait, okay. Before I say, does anybody else want to? And you, but by the way, also, this is supposed to be an honest discussion. Just because she just said that, and I like what she did, that doesn't mean everybody has to agree with Ashton. And I'm not only looking for good reports. You can be honest about. I mean, certainly, first and foremost, I just want to know: did you? Well, right. Okay. Does anybody else want to add or subtract or qualify or in any way respond to what Ashton just said? Honestly. Are you?
Yes, guys.
Good. Oh, okay. Okay, wait. So Remy just said yes. Thank you. Cool. Or wait, are you asking if you could say, you could totally unmute? Guys, also the mute thing, I get it, but you can be unmute as long as there's not a dog barking in the background. Okay. So,
no, I didn't get anything you said. You completely cut out there.
oh, sorry. Well, I'm saying that if you want to talk, please do. It sounded like you were saying something before. Do you want to?
Yeah, I'd like to say, I do not like the lack of instructions, if that's possible to change, because it's very open-ended and it's like there's no guidance.
That's a fair thing to say. That is, I mean, that's totally a fair thing to say. And you would not be alone. Many people have felt that in the past, at least at the beginning. Some people change their mind by the end, but some people don't. I totally do get that. Part of why we're having a discussion today, or part of what I will try to give more and more guidance for each lab based on what your experience was last. I will take that into consideration. I will also say that particular point, for good or for bad, that is intentional in the curriculum. It may not be good in the long run, so I'll think about it, but it's not an accident. It is for a reason. Partly because the nature of real experimentation, I mean, in the long run, well, so I don't want to get too far. That's totally fair. And I will take it under advisement. And I'm not rejecting it, but I do just want to distinguish, like, some things. Part of what I'm trying to find out here from everybody is like, you know, what went on and what you like and what you don't like. Definitely. Some things that you'll tell me that you don't like, when I find out about them, I'll be like, whoa, that happened? Wait, that wasn't supposed to happen. Oh, yeah. Like, that was an accident that we better correct for, you know. But other things, like what you just said, I'm thinking, okay, fair enough. Like, I totally get why you don't like that. That one's not an accident. It is part of the deal. I'll still take it in advisement. But part of the reason that it's part of the deal is that what we have found over time, I mean, certain lab classes that we do, even in physics, like, to be honest, 203 and 204 have a lot of instructions. They do. Like, it's not like we can't do it. But part of what we've found over time is that the real nature of research, of science research and science experimentation, the real hard part of experiments is actually that true experiments in the world are not prescripted by somebody else. That the real hard part of actually doing an experiment is designing it, is going from figuring out what you're trying to answer to how you would go about answering that. So in a way, that is kind of the skill that we're trying to teach here. But I'm not trying to argue with you. Like, I totally get that it is super frustrating. It definitely makes it harder and more frustrating to not have written instructions at the beginning. And again, I'm taking you seriously. Like, I may try to give you more instructions as we go. They might not always be written, but I will. But And I will also say that for some people, that's a super frustrating thing at the beginning. And then it starts getting more comfortable and then they like it more because then they have more freedom. But we'll keep checking in on that because we will have these discussions every week. So you can keep telling me whether it's getting, I think one thing I'll really be interested to hear from Remy or anybody else, like, and again, I'm saying this to everybody, like, let me really be clear. I would hate this. I mean, when I had classes like this where they were free-form and open-ended, especially in the lab, I hated them. And that's not, I'm not saying that dismissively, like, and I resented them. And I didn't like them better by the end. Years later, sometimes I liked the fact that I had to experience it, but I didn't like them better by the end. One thing I'll check in with Remy and everybody else as we go is whether you're liking it less and less or more and more, or something like that. Because that's also interesting data, but I will take that seriously into consideration. Wait, and there's things, but fair enough. And I appreciate the honesty. We should keep going with the honesty. I want to hear other things too, but also there's things in the chat. Let me just look in the chat. Wait, okay. Okay. Oh, cool. Oh, thank you, Ari. So I'm just reading the chat and it's public so everybody can see it. So thank you, Ariana. I see that. Oh, interesting. This is all very interesting. Sorry. So Ariana, thank you. And Sylvie, thank you. And wait. Oh, and so Remy, thank you for following up. Thank you for hearing me and taking me seriously. Thank you for being polite. And let me just say to everybody too, notice, like, I totally, Remy didn't like something, totally respect that, totally get it. And I can identify. I also appreciate that Remy is like, not like bombing my house over it. Like, he's just like politely, respectfully, like admitting something that's not working for him. Totally fair. And apparently he's hearing my response because he's responding to my response. I'm saying it is he, yeah. All totally fair. But now the follow-up, I really want to hear more about. Like, that's something I wanted to ask everybody about, because something might be going wrong there, or there might be confusion there. Okay, so Remy's response to my response, I want to get back to in a second. Let me just see what else is going on in the chat. Oh, yeah. And on Marina's point and Sylvie's point that things went wrong and that, see, I'm learning a lot from this. Yes, things always do go somewhat wrong. That's also, and so that goes to the grading and the penalizing and all that stuff that that Remy is addressing. Sorry, things are happening. I'm getting distracted. Things do go wrong in lab. That's an important point. And yes, the K, see, it's very helpful to me. It's awesome that you say that K is supposed to be constant no matter what M you put on the spring. The mere fact that you even say that definitely tells me that you understand something, all of you, and that you've learned something. You are correct. In principle, the K should be constant regardless of what M you put on the spring. And that is a good piece of knowledge. And you're right that if different M's produce slightly different Ks in the lab, A, that's frustrating for sure. B, that shouldn't really happen. But yes, C, that is kind of the nature of experimentation in labs, that things don't work perfectly in the lab, which is also why Remy is right, that if things don't work perfectly, if the data or the results don't work out perfectly in the lab, I agree, I don't want to penalize you for that. So let's talk about that in a moment. Like, let's make no mistake. I'll stand by certain things, like, you're not going to have perfectly structured labs in this semester. That is just the way it is. But do we want to penalize you for that? Well, no, I don't want to. So we'll address that. So especially if you understand, if you are telling me that you understand that you should have gotten different K value, that you should not get different K values for different M values, right, you're correct. And if you did, that is not something I want to penalize you for. In fact, all the more I want to reward you for the honesty of finding that out and accurately reporting results and not fudging them and all that. So that's very valuable information to me. Like, I'm going to keep going on and just reading. So that relates partly to the Sylvie thing, partly to the Marina thing, which I keep saying Marina. Oh yeah, yeah, it is Marina. We talked about that. You're right. Okay. And then Jonathan.
Yeah, you're right. You have it good.
Okay, thank you so much. I appreciate, and that's points, that's participation.
Yay!
I love the, yeah. See, you guys are saying you like my energy. It's your energy. I'm totally, it's like, all right, also, Professor Talley mentioned that. Yeah. Yeah, no, you're definitely right that this K thing does happen from time to time. It does bother me. It shouldn't happen. I don't know exactly why it is. I mean, when you say it could be the setup itself, something about the setup for sure, but I don't know what aspect of the setup. Okay, this is good feedback. And we're going to stay on this for a while. There's a couple, and again, we're going to do this every week. Okay, not always this. It's going to get tighter and tighter and more efficient, especially for those of you who are looking for a little bit more concreteness and more clarity or more specific guidance. This whole thing will get tighter as it goes. It always does. But for sure, every week, we're going to have a little period where we discuss what just happened, and we're going to discuss what will happen so that you're not groping totally in the dark. Now, at these few first weeks, we're going to spend a lot of time on this. That's why I'm not too worried about any other homework assignments. Like, I want to make sure we're all okay in both parts of this course. So forgive me if we're going to take a while on this right now. So I still have more questions and more. I want to hear from even more of you. And I'm not forgetting. I really need to respond to part of what Remy said, and I had a whole speech or a whole thing about prepared for that anyway. But forgive me, before I get to that, before I get to penalizing and stuff like that, let me just ask: did you guys get to the? Did you get to the point of actually making graphs?
Yeah, we did.
Yes.
Awesome. And did you, and I understand, or I'm inferring from what you're telling me, that you may have had to sort of pick a particular K value, even though it was sort of changing from M to M. And I might ask you how you did that. I don't know if you averaged or you just picked one, but once you had a particular K value, were your graphs more or less straight lines? Or, I mean, what did you see in the graphs?
It's kind of straight, but not perfectly straight.
Okay, that's fair. And it was like X on the X-axis and F on the Y-axis. Is that what?
What on the X-axis? I think we had the grams on the X-axis and the displacement on the Y-axis.
Okay. Oh, okay. Interesting. Okay, well, we got to talk about that. Okay, cool. So it was kind of straight, but not perfectly straight. Fair enough. Okay. And can I ask this too? How did you this answer might differ from person to person, but what software did you use to make those graphs?
Google Sheets.
Okay. And that's everybody, Google Sheets? Okay. So
Excel.
one thing, or an Excel. Okay, similar. Okay. And but literally, so everybody, am I comfortable? Raise your hand if you did make a graph. If you got to the point of making a graph, is it okay? Cool. Or electronic hands if you're okay. Cool. So is that it looks like that's okay. Wait, we're gonna do the control of the experiment. Let me ask. Keep them up. Wait, raise your hand or electronic hand if you can hear me right now. This is the control of the experiment. And keep them up for a second. I'm just like kind of making sure. Oh, you even just showed a bit. Okay, cool. That's almost everybody. Wait, and Fatima, and Ashley, and Nicole, okay, cool. Thank you. I know this is obnoxious, but I'm just, okay, that's good. All right, thank you. All right, so you all made a graph, pretty much. Okay, and I will say one thing down the road, one goal, we're eventually going to want to use Desmos. We're going to want to learn how to use Desmos to make labs. Desmos is to make graphs. It's not crucial yet, but it will get more and more important because Excel and Sheets is good to a point, but then it gets limited. So eventually we're going to want to use this free online application called Desmos, Desmos. I'm just warning you that right now. You might even want to, I should almost assign it as homework, but you might, if you have I'm just warning you that soon we're going to want, it's not hard, but you may want to play around with it. It's online, it's free. It's literally just like DesMos.com. It will be more helpful to making graphs next time. And we're always going to have to make graphs, but okay. So you made graphs. They were sort of straight, not perfectly straight. Okay. And you, okay, I like the fact, I mean, all right, let me ask. Again, I'm a little bit biased here. What I think what I'm hearing is good. You could still say more negative things. It's totally fine by me. But if you actually got, oh, well, wait. The most important question. If your graph was like sort of basically straight, not perfectly straight, of course, because it was, but if it was more or less straight, do we all think that the ultimate statement was true or false? Like, is f equal to negative kx or not? Is that, Jake, is that a yes, or that's you're raising your hand to say so, or?
So for this lab, I think most of us already knew that to be Hooke's law and knew that to be true.
Okay.
So because our data didn't necessarily like align perfectly, it was easier to say, okay, yeah, it does support it because we already knew it was true. But as we like move on in the course and we're learning different formulas that we don't necessarily already know, if we continue having these same issues like in the labs, then if our data doesn't like, where is the line of like our data supports or our data, doesn't support this? I think that's where we're all kind of confused.
All right, no, that's a great question. And that may dovetail with what Remy's getting. That's very fair. So very fair. And yes. So in fact, one way, okay, so the real answer to that, there is an actual answer to that, but it is a deep answer, and I'm not sure that we want to live by it. The real answer to that is that we have to do uncertainty analysis on our results. And if we do a proper uncertainty analysis, we can tell whether our result, like there is a way, which I'm going to teach you at some level. I mean, you've seen sort of before, but not, I don't think really before. There is a way to actually acknowledge that everything that happens in lab is to some extent uncertain, but there is a way to certainly, there's a way to be precise and certain about the level of uncertainty, believe it or not. I mean, this is why people trust science in the first place. There is a way to look at a graph that's not perfect and decide whether the level of imperfection is enough to throw it out or not, which I think is basically what Jake is asking. Like, I mean, or let me back up. Like, I'm pretty sure Jake is saying like, okay, so if we look at something and we're like, it's not perfect, but nothing's ever perfect. Like, yeah, where's the line where we say, where it's okay to say, well, it's not perfect, but we kind of think we know what the answer is, versus saying, well, like, if we really don't know what the answer is, and this really is free form, real research, how do we know whether we're allowed to throw this out, whether we should throw this out or not? There actually is a way, and it's called uncertainty analysis. And I am going to teach you guys that. And there is a procedure. And maybe this will end up being a sort of compromise for all of us, where I can give you a strict procedure for that, which might make Remy and other people a little bit more like happy, because it will be a strict, clear algorithm, and I will give it to you. But also it's strict enough and detailed enough that it can get kind of annoying and restrictive at times, and might also show us like why we all sometimes want to be a little bit more informal. But the answer is a thing called uncertainty analysis, which I may or may not really be able to develop by the end of today. But it's a very fair question. And let me say this to stay on this question for a second. Is there anybody who feels comfortable showing me a picture of, does any of you have a graph or the graph with you that you can share screen for a minute? And I won't judge it, and I'm not going to penalize you for it. And I want to talk about the penalizing. But yeah, like even before we get to grades, Jake's question is very good. Like, where is the line between, like, if we actually don't know something, how do we know what the right answer is? It's totally fair. So does anybody have a graph that they actually want to show me from last time where I could see how really not straight it is? No. So what does that mean? Oh, that's interesting. Okay.
I have one pulled up. I don't know how to share my screen.
Oh, okay. Hold on. Okay. You haven't pulled up. Great. Okay. Let me see if I can give you. Okay. You have screen sharing ability. So if you go to, hold on, if you go to, on your side of Zoom at the bottom, it should say share screen. Wait, you didn't just share. You didn't just share the file. Oh, well there. Oh, okay. Oh my God. Wait, and Eugene, I totally see you. Oh, great. Oh, and much of you did. By the way, wait, this is great. Oh my God. Wait, this is totally great. All of you. First of all, please, I think, yeah, we already opened up the portals for participation. Like Jake is right now sharing a screen. That's definitely somewhere there's a portal for that. And if there isn't, I'll make one. And then those of you who just shared file, I think if nothing else, where it says a picture is worth 1,000 words, I think that's the name of the one of portals. Definitely submit to that. Like, this is great that you're all sharing this. And maybe I didn't make a separate one for sharing screen versus sharing image in there, but I'm definitely seeing that you're all sharing files. That's great. That's great. Now, all right. But now, right now, I'm just going to deal with the one that Jake just shared. And I want to say, first of all, this is way better than you guys were leading me to expect. Like, oh, wait, what's happening? Oh, he's doing, okay. Like, when I look at that, oh, that is freaking straight. I mean, really, like if you're concerned about, I don't mean this, my tone of voice is wrong. That is much better than I was getting the impression from what you guys were saying. One thing about it that's a little, but wait a minute. Those results are very good. I'm still not answering your general question of where's the line, but like the fact that, okay, and I'm going to look at the files. Thank you. I'm going to look at the files that you all sent me. This is great. Oh, would some of them just appear in the chat? That's so amazing. Yeah, wait. Oh my God. Wait, what's going on with it? Eugene's is so straight. Wait, I mean, it's almost two. Okay, there's a couple of things I have to say here. The exact answer to Jake's question is a longer answer than I can give right now. Like there is a procedure. And if we end up making it a big part of this course, because it sort of brings everybody together to feel confident about this course, then we will. But it is a longer answer of exactly how you analyze uncertainty. It is a longer answer than I'm going to give right now. But on a rough level, the fact that, for example, in Jake's graph, he had this scatter plot, he had a bunch of dots, and then he was able to draw a line where really, like, some of the dots, like half of the dots are on one side of the line, and half of the dots are on the other side of the line. And no dot is particularly far away from the line. And most dots are about the same amount from the line as the other dots. Like, that's a very crude qualitative way of saying, like, yes, that's good. Like, it would be like, of course, no matter what your dots are, you can always have Excel pick some line that is the best fit line. It's true. You're right to ask. Your dots could be all over the place, and Excel will still draw a line if you ask it to. But the thing is, you would say that the line was not really, you would say you wouldn't want to accept the line if like some dots were super far from it and other dots were super close. That's not going on here. Like, the lines are pretty evenly, the dots are pretty evenly distributed around this line. I think it's a very good line. I think the line that's in the chat, or at least one of them, sorry, I'm just looking at the chat, is at first blush looks like even better, or not better, but even more like, yeah, I don't think you're fudging things to say F equals negative KX. But now if we're being really honest, or because again, Jake is right to ask, like, how are we, well, okay, we already knew this equation, folks. So, like, duh, but what are we going to do next week when we don't already know the equation? And yeah, I think the one I'm going to send you for next week, I think you very possibly don't already know the equation. So fair enough. So one thing that we have to be careful about, I want to ask you all, is there a particular, Oh, and you, okay, thanks. Okay. One thing about the thing that he was just sharing, one really important point in any graph, if it's a point in a graph at all, then it's usually the most reliable point, is the point 0,0. One thing that's a little confusing to me about at least the one I was just looking at, I'm going to look in the chat now, is why was it a deliberate choice that I'm looking at, is it a deliberate choice that 0? Oh, okay. So right now I'm looking at Eugene's. I mean, I'm not screen sharing it. I guess I could actually, if you don't mind, I'm going to. And we're just being honest here. We will get to the issue of penalties and grades in a minute, but I hope you're getting all of you are getting a message. Like we're talking, I want to the other reason my whole grading policy is what it is I want to be able to freely discuss physics with you guys and and improve in our physics as strongly as we can without the stress. I want to take risks in physics and get better at physics without it thinking that that's going to threaten our grades. Like assume in one part of your brain that your grades are going to be okay and just shut down that part of your brain and then just turn on the other part of your brain to actually look at the physics. And I'm saying that to say what I'm going to do now is share. I see there's something going on in the chat, but I'm going to share. I'm going to try to share.
We actually appreciate that because a lot of these science professors, the way they grade, it's so stressful that you can't even focus on enjoying the material because it's just constantly on your mind. I have to study, and then you just end up not enjoying it. So I just appreciated that you're trying to make it less stressful, and that way I feel like we could learn more effectively.
Wait, I totally appreciate that. Like, honestly, wait a minute. I totally appreciate that. I'm not trying to have a love. And because I was like trying to screen share and share the graph, I'm not even sure who, not that it should matter, but I'm not even sure who just said that. Was that Nicole or wait, I'm not even sure who just said that, but.
It was Marina.
Oh, Marina. Okay. Marina. So, all right. So first of all, thank you for saying that. And again, just because some people are saying that, and I do appreciate it. And yes, like what I'm trying, like, and I know this is not working for everybody. Don't think at any moment, just because I'm taking a compliment or giving a compliment, I understand that at any moment that one person saying something nice, that doesn't mean everybody in the room is satisfied. I get that. But yes, I appreciate what you just said. And let me tell you, like, I love physics and I've been doing physics for a long time. I don't even know if I mentioned this. I mean, I've been teaching for 30 years. I've been teaching at John Day for like 12, but I've been teaching for 30 years. And I've been studying physics for a long time. And let me tell you, I had a lot of really unpleasant experiences along the way, unpleasant science experiences. And many times along the way where I almost wanted to stop or did want to stop because it was so stressful. So like, yeah, like, right. I agree. Like it can be very stressful on its own. It just is at times. But I feel like there's ways it can be unnecessarily stressful that I am trying to cut down on. So I appreciate what you're, this means for everybody. I can't do exactly what works exactly for everybody because everybody needs something different. So I'm constantly trying to just please encourage all of you or remind that I know that what you guys need are different things. So if I'm doing something that's working for one person at one moment, it might not be working for another at another. Like even this whole unstructured lab thing, I think it's great for a lot of people. I know it doesn't work for everybody all the time. So I'm like trying to hear that, but I can't be perfect, but okay, anyway. So I appreciate what you're saying. And if nothing else, even if this, okay, so look, and I still want to get back to Remy's point about the penalizing. Yeah, like we're going to talk about the grading system again in a few minutes, so I can reassure you that at any moment, even if you hate everything that's going on or you're bored or whatever, at least I will say probably as long as you're still sticking with us and even hating it, you don't on top of that also have to hate the fact that you're also after all this going to get a bad grade. At the very least, you can hate this and it won't mess up your future because you'll still have a fine grade. Like I'm saying that in part to what Remy said before about penalizing and stuff. I can't necessarily change the whole way we do the whole lab program. It still might be miserable for some people, but no, you won't be penalized for your misery. That is what I'm trying to say to everybody. And I will address that more specifically in a minute. So yeah, I really will. I keep saying that, but I will. But what I want to say right now, right, is to get back to the physics. If you're sort of trusting me that whatever I say about the physics now is not to penalize you, is to learn the physics. Like, yeah, I'm looking at, I think you're seeing on your screen, right? You're seeing, I believe, Julian's graph. I believe you are.
Eugene.
Okay, it is. Now, wait, why are you laughing? Wait, are you laughing because I'm pausing like this?
No, because you pronounced it backwards.
Oh, wait, sorry.
It's Eugene. It's fine.
Oh, no, right. Because I wasn't looking. No, you're right. So, I mean, of course you're right. It's your name. Of course you're right. Sorry. Right. I was actually picturing it backwards. I totally was. All right. Eugene. Okay. I see it now. Okay. All right. So let's talk about this graph for a second. First of all, and I'm gonna be totally honest, like, right? Okay, we're all gonna get A. Like, this is not a criticism. Like, I totally appreciate the guts and all that. This graph is so perfect that it's scary, right? Like, honestly, this graph is so perfect, something's wrong, right? And I don't mean something's wrong with Eugene. I don't. And I don't mean something's wrong with your name, but I mean, like, actually, there's no way anything in the lab could be this perfect. So something is a little bit funny here, right? In fact, I am shocked. Right? One thing, can I just ask, honestly, you did a scatter plot first, right? You got those points, and then you asked Excel to do a best fit or spreadsheets or whatever. I mean, sheets. And you asked it to do a best fit line, and that was a line. Is that correct? Like that? Okay.
Yes, we actually did calculation and plugged it in, and we're like, oh wow, it's actually straight. But while we were calculating during the calculation of like the meters and kilogram, we were actually saying to teacher, like, there's like a how do you say it? It seems like they balance out like 0.25, 0.5, and the difference between like the kilograms, like it just balanced out. So we're like, oh, it seems so perfect. We actually discussed about that. And then when we graphed it, it was expected, like as we talked about, like the graph showed up as what we expected.
Okay.
Yeah.
Oh, all right. So that's amazing. Okay. And, wait, there's something in the chat too. Sorry.
Oh, and also the question was, we weren't sure if we were supposed to start from like 0 displacements in meter and 0 mass kilogram. So
right.
We just started off as 0 kilograms, and there was a 0.02 meters displacement when we started as a 0 kilogram.
That's a very important question. That's part of what I want to get at by sharing your screen. That's definitely, and I know Ashton has her hands up. I'm going to call her in 1 second, but let me also say that someone put a question in the direct chat like a million years, like 7 minutes ago, and I didn't acknowledge it. Someone in the direct chat said something about the 0, 0. And they said the 0, 0 did not give us a mass nor spring constant. They wrote in the direct chat, no force is applied when there's no mass. So I thought it was okay to add it to our graph initially. No, that's correct. I do want to get Ashton in a second, and I want to address all this, but I want to say, no, absolutely. I think 0, 0 definitely is a point. It is a point. It may be the point that you know more definitively than any other point. It's definitely the case that when there's no mass, there better be no force. So 0, 0 is actually a point, like, and you can know that even if you mess up all your data taking. So 0, 0 is a point. It is, right? Which is, so you definitely can put it, all of you can, and we should know that for the future.
Okay.
Oh, no, okay, sorry if I'm yelling. Okay, but that's also good news. It's good news. And again, I will get Ashton in a second, and I will say more. It's also good news because honestly, if on this graph, for example, if they put 0, 0, I believe that then the straight line wouldn't look as perfect.
Straight, right.
Right, which is good because I would actually believe it more, right? It still would be very, very straight. Like I still like this line, but it would be a little bit, then at least, okay, now I see that we actually were in, right. Okay, so clearly Eugene gets what I'm saying. Okay, and there's still something I still want to say about Jake's thing, but okay, hopefully we're making progress here. Ashton, Go. Sorry.
So I don't know if I'm overthinking this, because when we were discussing having 0, 0, my whole rationale was that because we did mass and displacement, that the spring had like, because on the bottom of the spring, there was like something that, you know, kind of held the weight. And my rationale was like, obviously that has mass to it. So like there has to be mass in the spring. So I thought even if there was like almost no displacement, there's still a minuscule amount of displacement from the thing that held the weight on the bottom of the spring that pushed the spring down. So it couldn't, like, theoretically it couldn't be 0, 0 because there's still mass on the spring pulling it down, even if it's minuscule. That's probably me overthinking it though.
No, wait. You're not overthinking. That's great. That's great. I don't even know what overthinking means. I mean, no, and we're here right now. We're here to overthink. We are here ideally to bring all of ourselves to like a point of satisfaction. We can't do it every single time, but we're definitely here to, you are not overthinking. That was good thinking. And again, let me also say, if you guys spent a bunch of time in the lab, like feeling like you had no clue, you didn't know what to do, you felt good, like unsupported and confused, but then you talked, and then there was more feedback from the instructor, and then there was progress, and eventually you landed on graphs that look like these graphs. Let me say again, by the way, that is an appropriate experimental experience. Remember, and if there was a lot of discussion of the kind that Ashton just was saying, like even if there's an answer to what she's saying, and I think there is an answer, and I think I'm going to say it in a moment, but even if I give an answer that resolves it, that doesn't mean she's overthinking by saying that, right? Please remember, the whole deal of science, and particularly real science research, real science experimentation, is you don't know where you're going to end up until you get there. That's why it's experimentation. It is the feeling of the unknown for a while. Experimentation feels very insecure and anxiety provoking and confusing until it doesn't. Like, that's why it's experimentation. And by the way, it's the flip side of what's been awful about, you guys have been tortured in two ways by science for most of your life, right? Science is either torturous because you have no idea what's going on and you're groping in the dark and you don't feel like you know what's what the question even means and what are you doing, right? Or someone can take you by the hand and tell you exactly what to do, but then it tends to be the case in science when people tell you exactly what to do, which you think you're looking for a minute, then they tell you exactly what to do so strictly and rigidly and rigorously and quickly that you end up having like no free will or no feeling of your own mind or no feeling of investment. And all of a sudden you're brought to a certain place. And if you fall off that place by 1 millimeter, like you have an F or whatever, science is crazy that way. What I'm saying right now is, first of all, this kind of thinking that Ashton just did, this contemplative, that's what we want to be doing at the early stages of an experiment. Then we want to refine, or a discussion. Then we want to refine, get guidance, and eventually land at a graph. You guys all landed at a graph. You got somewhere. You started off by feeling like you didn't know what was going on. You had no instructions. You all ended at a graph. And even if the graph sucked, which I don't think it does, but even if all your graphs were totally wrong, you ended at a graph. That means you got to scientific resolution. I'm already thrilled. Now, I actually think your graphs are really good. But so on Ashton's question, though, because this is going to come up a lot, actually, it's a really good point. She's saying, now, hang on a second. She's saying, well, hang on. Like, even when we put that, I don't even know what you call it, but the thing that holds the mass, even when we put that support at the bottom of the spring, already that had a little mass, right? And she's right, it did. It did have a little bit of mass. And she's like, wouldn't it be a lie to not acknowledge that? Yes, it would be a lie to not acknowledge that. But then she also said something else that's interesting. She also said, and didn't the spring fall down a little bit already? Like, wasn't there a little bit of displacement because of that support thing? Yes, it did. And it would be a lie not to acknowledge that. But now notice, both statements are true. The little support thing had a little bit of mass, and thus it caused the spring to fall down a little bit. And then it sat there. That place that the little support brought the spring to That's now our equilibrium position. Like now we're going to call that 0. Just like now we're going to call that 0. So every bit of mass that we put on the stand is now what we're going to count as additional mass. And every bit of displacement that this new additional mass brings us away from the platform place is what we're going to call the additional displacement. In other words, we're setting our 0 to wherever the platform brought the spring. And in effect, what we're doing in a way is we're just counting that platform in the same way that no one ever counted the mass of the spring as part of their mass in their graphs. And for that matter, no one ever counted the length of the spring as part of their displacement, right? Like the spring already had length. It was hanging down from the hook on your ring stand, but we didn't, and this is not an argument, I'm just explaining, like, this is a really good point. But my ultimate summary, as I'm saying, is where 0 is always up to the user. It's up to the researcher. 0 is not objective. 0 is not the center of the universe or something like that. And similarly, 0 is not the top, or is not the bottom of the ring stand. 0, when you put the spring on, the spring already has mass and it already has length. But this whole experiment is what's happening at the bottom of the spring. So we ignore the mass of the spring and we ignore the length of the spring. We start saying to ourselves, okay, we're going to just look at the bottom of the spring. Well, we extended the spring with this platform. The platform had a little additional mass. The platform also brought the spring down a little bit. Wherever the platform sits, we count that as 0. And now our whole graph is really about what's the additional displacement that is produced by any additional mass. It's all in comparison to the 0 that's set by the platform. Is that this is not an argument to what Ashton's saying. It's an acknowledgement. Like, but it's a really good question. But the ultimate answer I'm saying is we set 0 to be wherever the platform was, and therefore we set 0 mass to be whatever the platform is. Does that make sense? Or, well, Ashton's hand up. Okay, go. Sorry.
Just to paraphrase from my understanding. So we are reestablishing a new equilibrium for the spring because of we're adding the mass of the stand. So that's being okay. So do you want us to say that in our whatever we're handing in? I don't know, we can't really call it a lab report because it's not a lab report, but do you want us to state that? Because obviously in my group is with Eugene, so we're gonna have to add the 0. Do you want us to state like 0 is here because we reestablished the equilibrium with this, like the stage, for lack of a better term? Or would you just understand that, or Mercedes would just understand that from looking at it?
Very fair question. Right. Ideally, you would say, ideally in every lab report or every lab experience or in every physics thing, there's a moment where we define our terms or we define what we mean by 0. And as long as you explicitly say by 0, we mean the equilibrium. By 0, we mean the position that the spring with platform sits naturally. And by 0 mass, we mean no mass added to the spring with platform. Like, yeah, if you just say one sentence, like, this is what we mean by 0, that's totally sufficient. Yeah, if that may, okay. Is that, okay. There's just one little question. Can I go back? Or are there other questions on this? Is this good so far? Are we good? We will. Okay. Oh my God, I'm not quite sure what Catherine's doing, but okay. So I want to go back to Jake's thing for one. Well, I want to go back to a lot of things. And again, this is not a criticism either. This is an inquiry. So I'm asking Jake or anybody in Jake's group or anything. The one thing so to everybody, I am saying, yeah, 0, 0, I think is a point on your graph. It is. And a point that you put in your scatter plot before you have Excel or whatever choose a line that goes through all those dots. Like, yes, I think 0,0 is a point, and I think it means wherever the platform was sitting without any mass on it. Is there, well, I guess just to put it, to me, it makes the most sense for 0,0 to be where the two axes actually intersect. Like I guess what I'm wondering is, and maybe there's no answer to this, was it a deliberate choice or an accidental choice that it looked like on Jake's graph, it looked like 0 for the y-axis was one place, but 0 for the x-axis? Or what, well, I guess, was that exactly because of what Ashton is saying and maybe other people, like, is that why your axes seem to not, it seemed like the 0 was different on the, am I making any sense, Jake, or any?
You are
Yeah.
absolutely correct. That was unintentional. That's just the graph that it came out from our data. I didn't do that on purpose.
Oh, okay. All right. So that's no big. Okay. So one thing is with your, if you were to readjust that later or something, or just make sure that we might even find that your graph looks even more straight for whatever it's worth. Okay, we're gonna move on. There's a couple of things I just want to establish again. I still have not fully answered Jake's question about how do you actually know whether something's good enough or not. I will say next week, the lab is harder next week. It's more unknown. It is. So Jake's question is very well taken. But I will say that once again, you'll agree or disagree with the proposition I give you, depending on whether your graph is straight or not. So I'll tell you right now, if you take a bunch of data next week and your data falls into a formation that's at all reasonably like what you guys are showing me here, oh, you can definitely call that straight. I mean, for sure, if that helps. That's still not like a concrete answer, but the way your data fell is very convincing to me. And next week, you're again going to be asking whether something's falling into a straight thing or not. And we're going to get to that in a couple of minutes. The other thing I still have not acknowledged is this business of penalties. I want to get to that. I think it's pretty important. We assure ourselves of that. But I do have one other comment or question. The reason I'm sort of, well, it seems to me that what you guys are telling me is that where you had a lot of experimental uncertainty and a lot of doubt or a lot of frustration or a lot of non-trustworthiness was in this whole business of K being constant or not. Like I'm hearing that, and yeah, that happens a lot, and I'm still not sure why. But I'm not surprised to hear that you were frustrated to find different K values for different M values. But then it seems like even with that, your data was remarkably regular. So I want to make sure I understand. Am I right to think that you got all these different K values for different M values, but then you just, one way or another, each of your groups just picked a K value and made a graph from that? Is that why the graphs look so straight? Like, I mean, there's no way those graphs could look that straight if the Ks were wildly different, unless you had just picked a given K. Is that what you did?
So for my group, we got K values that varied from like 15 to, I think the highest one we got was like 17.
Oh,
But because we chose to graph ours using like the mass, which we could have also used force, I guess, against the displacement. We didn't like the K isn't necessarily like directly represented on the graph at all. But I guess it indirectly is because that's how you solve K. That's from displacement and force. But we used the same data. We didn't just pick one value set. It's all of the different. We did 5 different trials with the different weights, and that's what's represented on the graph.
okay. All right. This is really good. Again, look, maybe at this point I've just entered. I feel like this is a really good class. I'm going to keep saying that. And you might think I always say that, and I don't. I always try to be high energy, obviously, but no, you guys are definitely doing something here. And I know we're sitting here for 2.5 hours and all of that. but I feel like a lot is going on here. And he just told me two major things I want to respond to now to all of you. And all of you who are talking or putting things in the chat, you're making a lot of sense. Honestly, like I feel, and you're saying things that I don't feel like you could have said 2 weeks ago. Like you're not just like say, I mean, it feels like things are happening in this class, just saying. So two things on what Jake just said. First of all, they did answer my question. Second of all, if what you guys are telling me is that your K values were ranging from like 15 to 17, let me say again, and I'll try to support let me say, oh, that's your concern? That they were varying from 15 to 17? For whatever it's worth, that is very reasonable. I was getting the impression from the way you were talking that they were like wackily all over the place. Now, I know that you don't have the perspective I have. Like 15 to 17 may sound like a very big variation to you guys. That is not a very big variation to me. And what I owe you, what you deserve, and again, this goes to Dake's question, if you're thinking, well, how do I know what a big variation is or a small? Fair enough. Maybe you don't. And that's what I need to explain to you. And it's like maybe the biggest thing that I'll try to teach you by the end of the semester, because it really is the nature of science. But I am telling you, for whatever it's worth, 15 to 17, that is not bad at all. That's much better than I was thinking you were telling me. And I'm saying this as a compliment. Like, wow, I thought they were like crazy. So that's number one. It also, now number two, Jake is right. I hear Jake loud and clear. Like you didn't directly use the K's to make your graphs. I understand that, but K is readable off your graphs. I'm going to get to that in a second. But now that I'm hearing that your K's only varied from like 15 to 17, no wonder your graphs look so straight. Your data is much better than I think you think it is. Let me pause for a second and say, can anybody, maybe not Jake, just because obviously I've heard a lot, maybe someone that I haven't heard from yet. Can anybody tell me? And I agree. I see that. You didn't use K directly to make your graphs. I agree with that. Like, I understand that. But can anybody this would be a big question. Is there anybody who feels comfortable, even in the private chat, saying like, how could we read K? Like, how could we infer K from looking at your graph? Like, it is somewhere in your graph. It's not a point. I agree. It's not a set of points, but K is implicit in your graph. Once you make the line does tell me what K is, if I believe the line. Does anybody want to take a stab at where K is being represented in the? Yes! Oh, sorry. Sorry, I just saw something. Did I say yes? I'm excited. Oh, and it is more than one person in direct chat. Word to the ship, comma, yo. Yeah. The whole point is that it's the slope. I mean, or technically it's the negative of the slope, because the way you guys arrange things, you've got this thing going up and technically it would be going down. But yes, like the slope of the graph, the rate of rise per run, the proportion of force to displacement is what K is. And so the fact that your line was pretty straight, that your slope was pretty constant, is because in fact your K was a little bit more constant than I think you think. So, okay, so no, that's great. So I think you really, right, oh, and good. Okay, and yes, looking at the, yay, I love you guys, okay. And I really don't, look, I try to like my class. No, but you guys, and especially for a group that is under direct, no, you guys are rocking. I'm looking at the direct chat. There's like all things happening in the, yeah. So I appreciate the feedback in the direct chat. And yeah, and then some people in the direct chat. So yes, it's all about the slope. Now, some people are talking about the units in the direct chat, which is very smart. Like, hello, science. Yes. How the units exactly work gets to me wanting to analyze, like, yeah, like, I may want to say a lot about that. Like, the reason that the units don't look like they work exactly is right, because your graphs are indirect. Like, this is where the whole thing of KY equals MG and what you're putting, Let me look again at one of your graphs. Hold on 1 second. I just want to see one thing. 1 second. You guys put displays. Right. I mean, truthfully, the way you guys ended up doing it, you have displacement on the y-axis and you have mass on the x-axis. So to be honest, what you actually see, mass is directly proportional to weight. And weight is, I don't know if I want to go into all these. What you worked out apparently in your discussion with Professor Talley. Should I do this? At any given moment that the mass is sitting there on the spring, mg is pulling down, kx is pulling up, right? So the force of the spring is equal to the weight pulling down. So the weight, mg, is what you're using as an indication or a output or a measurement of the force. mg, the weight the weight down is equal to the spring force up. So every time you're changing the m, you're changing the force, right? And then you're measuring that in relation to the displacement that resulted. It makes sense, the more I'm thinking about it, that you put displacement on the y-axis and you put mass on the x-axis. I totally understand why you did. I think that was actually very smart. I think that was very smart because you were changing your masses. So for you as an experimentalist, your masses were the independent variable, and then you were watching to see how nature responded in the displacement. So you're completely correct that your masses were like your input and your displacements were your output. I think that was very wise. I'm not being sarcastic. I'm not being like blowing smoke up the mixed metaphor, but so you have displacement on your y-axis and mass on your x-axis. But then if you think about the equation that we're trying to test is F equals negative KX. So in the equation, like F is the output, it is like the rise, and X is like the input, the run. So really we have to flip our units to test the equation. That's what, so your units are like the reciprocal of the units we would get in the equation. I don't know if that makes sense or not, but yes, I agree with you. The slope is what's telling us, in effect, the inverse of K. If you measure that slope and then multiply by 10 meters per second squared, like to convert the kilogram units to Newton units, then you would have the K. So anyway, but the fact that you all said slope in the direct chat means you really do know what's going on. And I really feel like you do understand. I feel like we did learn what we were trying to learn out of this lab. Honestly, I'm very pleased. And did it take you the whole period? Pretty much. I mean, did it take you the sort of kind of? Did you have any chance to try to do your homework at the end or no? No. So it took you. Wait. Yeah. Sorry, Fatima. We did. That means you did have a chance to do your homework at the end, or we did take the whole period. Sorry, we finished. Oh, okay. Some of you
we finished early, but we had like time, like around 30-40 minutes to go over the homework if we wanted to.
Oh. Okay. Cool. She didn't let you go early, did she? Okay, cool. Okay, all right. So listen. Again, I'm already predicting we may not even, well, I do understand that. What's in the chat. And I'll think about it. That one, again, there's a reason that I don't, I'll think about it. And if we keep going like this, I will think about it. I'll talk to Professor Talley. And by the way, the mere fact that he's saying that Remy's saying that does seem to indicate that I take it to mean that you weren't allowed to leave early, which is the rule right now. Like, at least I appreciate, I appreciate the respect. Like, you're saying to me, okay, we're doing what you're asking us to do, but now here's our complaint about what you're asking us to do. Fair enough. Like, better that than you just like rebelled and just left or whatever and didn't tell me. I will think about it. If you keep sort of doing what you're supposed to do, we might sometimes let you go early. Just to be clear, I'm really, as you can see, I'm really loose about certain things, a lot of things I like to think. And I'm really generous. I like to think about a lot of things. Some things I'm surprisingly strict and rigid about across the whole physics board. It's not your class, it's physics 101, 102, 203, 204. I'm really kind of a jerk about not letting people go early, especially at the beginning of the semester, but I'll tell you why. And I'm willing to think about what you're saying. The reason I don't like to let people go early at the beginning of the semester is I don't like people to get into the habit of then thinking that if they finish early, they'll go, because then people end up rushing a lot. Really, they do. And they end up, not you, I don't know about you. In past, if we let people go early at the beginning, then they don't, not only do they work quickly and sloppily, but for example, like the question that Ashton raised before, or the thing that like Eugen and, oh, did I do it again? Oh, no, yeah, Eugen and Jake are raising now, like, if people feel like they could go early, then they don't sit around and think about the kinds of things that Ashton raised before. And also if people, and I'm not arguing with you, Remy, really, like I'm taking it into account. And to be super honest, to get to the point, probably eventually I will let you guys go early. I will, if we keep going like this, or I'll tell Professor Talley to let you go early. But the reason I don't like to do it at the beginning is not only because then people stop, like they won't think about the kinds of things that Ashton thinks, and they won't take risks and make mistakes, which I really think the lab is supposed to be for you to explore and experiment and hit walls and bounce back off the walls and fart around and feel like it's unstructured. I do feel like a lab is supposed to be filled with like unstructured and like surprises and stuff. But the other reason I don't like letting people go early at the beginning is that what also tends to happen is that if some people still ask questions or do something, then their lab partners or other people start getting angry at them and thinking like, dude, just don't, you're wasting our, like, we want to get out of here. Come on, dude. And like, that's not fair for there to be a pressure on certain people to like get it quicker or stop their thinking because somebody else wants to leave. Like, and I'm not saying that would be you, Remy, or any, but I am saying it's a dynamic that has disturbed me in the past. So I like to set the precedent at the beginning that you're here and you're stuck no matter what. So you might as well make the most of it, and you might as well chill and relax into it and do, like explore around. But yes, by the end, we'll probably end up going early. I just don't like doing it at the beginning, but okay. Oh, funny. Okay. Oh, thank you for acknowledging, Remy. I appreciate. But I will, and I'm acknowledging you. Well, thank you. That actually makes me feel okay. And yeah, okay, Ashton, right. So wait, that's right. I forgot Ashton was in 203. Okay, but and again, I hope you all see. Again, I know this is like very inefficient that we're just like sharing and caring right now. I'm really, I want this to work for everybody. So I am hearing what all of you are saying. And apparently you're hearing what I'm saying, which is cool. We're gonna find what works as most ideally for all of us. I'm totally taking into account. I am flexible, like I will take into account, but yeah, that's my initial reason for why we don't do that initially. Okay. So, and again, there's as you can tell, there's definitely not going to be new homework due next week. Also, one other thing, if you're going to continue to roll, my main goal, I still want to set you up for the next lab. That's definitely my other goal, and talk about the grading and penalties. One other thing, and so even if we never get to the actual homework, I'm fine with that because we won't assign anything new. But one other thing on Ashton's, oh yeah, just to also be clear, because I do feel like you all are hanging with this discussion. It seems like you really are. And I know people have to take breaks and this and that because it's like so long. But as long as you're all hanging with me and rolling with this discussion and trusting that things will happen, even if they happen non-linearly, both in the lab and the lecture, then also to something that Ashton said about like, how would I put this in the report or the whatever you call it? I'm going to say right now, at least for this lab right now, I'm going to tell you, I'm happy enough with where you got and how honest you all and thoughtful you all are being with me right now in discussing it. I'm considering this discussion, and you all, like 50 of you shared screens. I mean, I didn't see all of them, and I apologize. I did, but you could still all, submit for points. If you shared not shared screens, you all shared like screenshots in the chat, and I didn't look at all of them, and I apologize. But like, or maybe I should, but I'm considering this. You're not going to have to do a report, okay, on this one. You will eventually on some. but like, we're good if you're good with that. And we'll talk about the grading like now. But this is good for me for now. If we keep paying this much attention in the lectures and in the lab and getting all these points for participation and doing the homeworks, I mean, yes, we're going to have an exam and yes, there will be lab reports, but we don't have to do one every week in order to learn or to get a grade. So for what it's worth, and again, that's the flip side of like other the weird unstructured nature. Part of the unstructured is we don't have to have the structure of having a full lab report if you're good with that. I mean, if that scares you, tell me privately for sure. But I don't think we have to put this into a formal report. Is Ashton, is that a bad thing or good? Wait, you just rolled your.
That's a good thing. I got
Oh, okay.
trauma from the formal reports from physics last semester, so
Okay.
I'm like thanking God right now.
Okay. Oh, cool. All right. So me too. All right. You're cool. Yeah. And just so well, it's funny. She said that that's also evidence to the rest of us. Like, yeah, believe me, physics classes are capable of doing formal reports. We have a million of them and their intention. Who did you must have had Walters? Well, anyway, I'll find out later, but yeah.
I love Walters. She was the best. I loved her so much. She talked about you all the time.
Well, she is okay. I love her too. And that, great. And yes, but just so all take a note. And I think if anybody talked to Ashton in private, they would also find out 203 labs are very structured, like maybe even they're different. It's not like we can't do it in physics. It's not like we're just trying to get out of it. It's just different classes for different things, whatever. Okay, but cool. I love Walters too. And when we have a chance to, you gotta add, I've got stories about Walters that are, well, I'm gonna say say one quick thing, right? Do you know, maybe I've mentioned this, you guys, Walters, so the physics professor that Ashton had last semester for 203, she's awesome. I love her. She has a husband who also used to teach here. He doesn't teach here anymore. His name is also Walters. They're married. She still teaches here. He used to, he doesn't anymore. Well, a long time ago, wait, have I told you the story? Do you know who I'm talking? Should I even say this? Is this worth it? Or maybe I'll tell you another time. Okay, whatever. No, that's another. Sorry, that's yet another Walters. Totally coincidence. There's three. Britannia Walters is a woman. She's not Hema's husband. That's another Walters. She also teaches here. You're right. I don't know how and she's awesome. I love her in a different way, whatever. But it's completely coincidence that they're all named. Well, it's a coincidence that she's named Walter. Well, it's not a coincidence. It's her parents' name. But yeah, no, that's a different thing. But good point. Okay, I'm going to go on actually. But remind me later. I have stories about all the Walters that are fairly amazing. Well, I'll say this. Hema Walters, the one that Ashton had last semester, and her husband, Joe Walters, who's no longer here anymore, they were students at John Jay a long time ago. Okay, they were in the science. They were students of forensic science. They met in chemistry class, like in their first year or whatever. They met in chemistry class. They started dating. Once they started dating, they aligned their schedules so that every single class they took for their entire college career, every single class with one exception, they took together and helped each other with all the work and they have two very different talent sets. They're very talented at different things or whatever. They helped each other in every single class they took at John Jay for the entire major, like no joke. And they were in my class. I mean, they were in my physics class. I loved them. They were so cute, whatever. And then I eventually hired them both as instructors, blah, 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 blah. And they were awesome. I love them. And quick aside, they got married and I was at their wedding. And they had me give a toast at their wedding. And what did I do for my toast? I literally found the first lab report they wrote for Physics 203 together. And I read their lab report at their wedding. There's like 200 people at their wedding. I read their lab report out loud at their wedding because it was so cute. And I don't mean cute in a condescending way. Like I love them so much. But their lab report that they wrote for Physics 203 together, their first lab report, it's pretty good. Actually, it's a piece of garbage, to tell you the truth, but I love them anyway. But the content was pretty good, but it was totally unedited, the writing. And it was so unedited that they didn't notice that in like certain paragraphs at the beginning, they would say things like, in certain paragraphs, they'd be like, I measured the mass on the inclined plane. I measured its velocity over here. And then I measured that the velocity over here was blah, 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 blah. And then in other places in the lab, they would write, we measured the mass of the velocity over here on the inclined plane, and we measured the velocity of the inclined plane. So like throughout their lab report, they went back and forth from first person singular to first person plural without ever noticing it, without ever correcting it. And it was just like, how married are you? Like you literally don't even know if you're the same person or not. They're so cute. Anyway, okay, I love them. All right. Anyway, okay. I want to go on to prepare for the next slide, but I want to address the wait. I'm just looking at the direct chat. That's awesome. Oh, that's great. No, she is. Oh, that's great. Okay, I'm totally psyched. Wait, and who did the rest of you? Sorry, last thing, as long as we're talking about this, all the rest of you were in 101 last semester. I know we've talked about all that, blah, blah. But who did you have for lab for 101? I forget. Or did we talk about this?
Britannia Walters.
You all had Britannia Walters for 101? Or no, some of you, wait, yes. Okay. I love her too, but she hasn't been working here as long. Oh no, some of you, so it was different too. Professor Lou. Wait, for what? For lab you did? Wait, you had
Professor Lou taught our lecture.
Right, that and I'm seeing, okay. No, that I definitely knew, but okay. And there's stories about Lou too. Anyway, cool. All right. You took physics in 2016. Wait, 2016 at John Jay? Marina?
No, it's a long story. I took it at Fordham, but then I didn't do so well. So then I went back as a non-degree, took it at City College. I forget his name, but he was like a old Russian guy.
Okay.
You might know him because you said you went to City.
Yeah, I did. And what an old Russian, well, there's a lot of old Russian. Yeah, oh my God. I actually do think I might even know, but it was so long ago. I don't even well, I'll think if I can think of it, I'll get.
I can go on my Blackboard and find his name.
Okay, sure. I'll be interested if you. Okay, but cool. But back to but yes, if you. All right, to everybody, I want to prepare you for the next slide, but I want to talk about grading for a second because the one other question I wanted to find out is wait, chat. Oh, okay. Fine, direct chat person talking to me about the device. Got you. Thank you. I understand. No problem. Thank you. All right. One other question. This is important too, especially if we're going to keep talking about all this. Or, did Professor Talley do the thing? Did she talk to you about the grading rubric of the 3-point scale, 5 metric grading? Did she talk to you about grading labs? No. Oh, okay. Well, no wonder people are concerned. Oh, okay. Wait, so as far as you know, you didn't get any grades at all for what you did that period? Is that like as far as you, so there was no grade discussion that, okay, wait.
She just told us to write down our data and our graphs and submit it by next Monday. It was due right before class.
Okay, I'm glad I'm asking this too. Okay, so first of all, I don't want to do, okay, thank you. And I thank you. First of all, so I don't want to create a confusion. I'm definitely standing by what I said, that no formal report is due or anything like that. Certainly nothing additional to anything. But on the other hand, to Ashton and to everybody, anything she told you that you've got to turn in, certainly you do. I'm not taking back anything. If she said you got to come in with your graph and your data, great, and that's good. And if she said that, then do that. I'm just saying there's no formal report or nothing, certainly nothing additional to that. And if at any moment I'm ever contradicting, you definitely all have to tell me. If at any moment I'm either contradicting myself or sending some confusing message between her and me, you definitely have to tell me, because I don't want to do that. And we'll have to make a decision, when ultimately, like sometimes her word will go and sometimes my word will go, but okay. So if she told you to bring in your graph and stuff next time, cool. I will tell you right now, to Remy's comment, everybody else, I'll tell you right now, if she's taking that, she's going to give you a grade based on like whether you did what you were supposed to do and did it carefully or thoroughly or not. She's not going to grade it based on accuracy. I promise you that. First first of all, but which is funny because I think it's pretty accurate stuff anyway. And even like the thing that I was talking about, the 0-0 being moved over, like in the future, that's something to maybe think about, but that's not something that any of us would be taking off points for right now, her or me. So let me get that straight. Now also, oh, do you need rest? Oh, yeah. Oh, okay. Oh, sure. Sorry, I didn't see the chat. Sorry. Oh, yeah. Actually, that makes total. Sorry, I missed it. Was it? Oh, it was 1 minute ago. Yes. 6:15. This goes to 7. Sure. 10 minutes. Sure. Yes. And you're saying 10 minutes. Okay. Sure. 6:15. I'll see you at 6:15. Okay. And I'm stopping the recording.